a ray of light going from one medium to another medium, it bends. That bending is called as refraction of light. Now, bending happens because there is difference in optical density, and because of the difference in optical density, there is change in speed of light. Light travels faster in a rarer medium, light travels slower in a denser medium. Okay, so that is about refraction. Why refraction takes place? That is called as the cause of refraction. So again, I'm repeating, refraction means a ray of light going from one medium to another bends. That is called as refraction. Cause of refraction of light because change in speed of light when it goes from one medium to another. Now, the third point over here is when light is going from one medium to another, what are the conditions where light goes undeviated? So number one, if the ray of light is incident perpendicular to the surface separating the two media, it will go undeviated. Another point is this is medium one, this is medium two, and a ray of light is going undeviated, even if it is oblique. That means that optical density is equal of both the medium. Optical density of both the medium is equal. When the ray of light is traveling in medium one and then in medium two, say for example, here this is the ray of light and now it is bending. So let us say that light is traveling with velocity v1 in this medium and v2 in this medium. Now this ratio of velocity, okay, v1 upon v2 will obviously be constant, okay, because if this medium is what is called as a homogeneous medium, light will have a constant velocity v1. When light is traveling in medium 2, it will have velocity v2. So the ratio of the velocity of medium 1 upon medium 2 is constant. Now students, this constant is called as refractive index. Okay, this constant is called as refractive index. Now you can also arrive at that same constant if you measure this angle that is called as angle of incidence, this angle which is called as angle of refraction, and then you take the sign of angle of incidence to the sign of angle of refraction. That is also constant. Okay, so if you take another value of angle of incidence, so suppose if you take another value of angle of incidence, you will get another value of angle of refraction such that that ratio will also be equal to the same constant. These two constants are same. So therefore, I can say that refractive index is sin I upon sin R, and refractive index is also called as velocity 1 upon velocity 2. Okay, so sign of angle of incidence is in medium 1, and that is velocity of light in medium 1. Refraction is in medium 2, and this is velocity of light in medium 2. Now, how do we write it? We write it like this. Okay, you can either use a letter n or you can use a letter mu. So, how do we read this? We read this as refractive index of medium 1 with respect to medium 2. Okay, so sin I upon sin R, which is written as n21 or mu21, that is refractive index of medium 2 with respect to refractive index of medium 1. This is refractive index of glass with respect to air. Refractive index of glass with respect to water. So when we say refractive index of glass, it is important to mention it is with respect to water. So when the refractive index of any medium is with respect to air or it is with respect to vacuum, then that refractive index is called as absolute refractive index. Okay, so that's another important term, absolute refractive index. So it means a ray of light is coming from air into that medium. So angle of incidence is in air and angle of refraction is in that medium. So that is the refractive index of a medium with respect to air or vacuum, that is absolute refractive index. So when you search online and you search what is the refractive index of glass and you get it as 1.5. So it means it is with respect to air, it is 1.5. Now, another point is, say for example, refractive index of diamond is 2.4. What is the meaning of that? Okay, what is 2.4 means? First of all, uh, glass is 1.5, diamond is 2.4. It means that if a ray of light is traveling from air inside diamond into diamond, it will bend more compared to that, compared to what it will bend in glass. So higher refractive index, more the light will bend. Also, when you say V1 upon V2 is equal to refractive index. So here when I'm saying refractive index of diamond with respect to air, so V1, that means velocity of light in medium 1. So that can also be written as C. And this is velocity of light in diamond. So 2.4 is C and VD. So C is equal to 2.4 VD. So let me type it out, what I mean. So refractive index of diamond is 2.4, means that velocity of light in air is 2.4 times the velocity of light in diamond. Another way to put the same thing is velocity of light in diamond will be 2.4 times slower compared to that in air. So these are the points that we can make. There are factors affecting refractive index. One is the nature of the medium. As I already told you, it's optical density. More optical density, more will be the refractive index. Then what you have is physical conditions like temperature. With increase in temperature, the speed of light in the medium increases. Refractive index of diamond is velocity of light in air upon velocity of light in diamond. That means refractive index of diamond is inversely related to the velocity, or basically refractive index is inversely related to the velocity of light in that medium. So what do you mean by that? If velocity increases, the refractive index will decrease. And here they are saying that if the temperature of the medium increases, then the velocity is increasing. That means the refractive index will decrease. So refractive index is increasing, optical density increasing. Then you have temperature of the medium. You have the wavelength. Wavelength of violet is less than wavelength of red. But refractive index of violet is greater than refractive index of red. Again, the logic is same, students. So refractive index of diamond will be equal to wavelength of light in air upon wavelength of light in diamond. So there is an inverse relation with wavelength. So shorter waves have a higher value of refractive index. So it means that if you have a violet light and if you have red light, which are making the same angle, okay, they are parallel. But you will notice that a violet light does bend more compared to a red light. Okay, it has a higher refractive index.